cross sections, other shapes, triangles and semicircles. So as long as you can figure out the area of the cross section, you have to know the formula to find that area, then you could do that and add it up all along. Because this is the idea of any cross section. It's just adding up all the areas of whatever your cross section is. So this part that's a to the x is dependent on what shape you're dealing with. Squares, you just square it. Rectangles, it's going to be length times width. And whatever rule they give you for the length and the width, often they just say they're always of height 7. And then it's like super easy. Okay? So let's look at different shapes. If they were equilateral triangles, you probably don't know this formula. That the area of an equilateral triangle is the square root of 3 over 4 times s squared. Does anybody know that formula? It's one of the formulas you collected along the way. But it's, how do we find area of a triangle normally? Base times height divided by 2. Here's my base, which is whatever s is. But they're using s as the base of that. Okay? If it's an equilateral triangle and you do height, does it make sense that that cuts that perfectly in half? If it cuts it perfectly in half, you'd have 60 degrees and 30 degrees. And this side here would be exactly s over 2. This side is still s. You could either use your unit circle values and use SOHCAHTOA, or you could do a squared plus b squared equals c squared. If I want to find how high this actually is for my h, can you see that s over 2 squared plus h squared would have to equal my hypotenuse, which is s squared again. This will be 1/4 s squared, and then that would give me h squared equals s squared minus 1/4 s squared is 3/4 s squared. And if you square root that, if I square root that, I'm going to get square root of 3 over 2s. Okay? So now if I take my base, which is s, and I multiply by my height, ooh, this be a 2? Oh yeah, and then I have to divide by 2 in the formula to get the 4. Thank you. I was like, oh, I got 2 and it's supposed to be 4. It's all good. No, it is all good. Yes. So once you plug that in, you would have my area. Oops. Keep it flat. You can really show here. My base was s. My height was root 3 over 2s. And that all gets divided by another 2, which gives you the 4 on the bottom in the end. So do you need the formula? I never have that formula memorized. I just think base times height divided by 2 and do some thinking to figure it out. And that's the thing you need to do. I find equilateral triangles don't show up a lot, right? Because on the exam, what's the one struggle people deal with? Is thinking. You don't want to think very much. Just want to be able to do something. And if you come across something new like this that you haven't thought about before, you get into panic mode and thinking goes out the window. So I would say not very often that we get equilateral triangles. Okay? But here's an example. We have that same shape that we've been dealing with all along. It forms the base of a solid. Which way should I draw my horizontal line? It's perpendicular to the x-axis. So I'm going to draw a line like that. So it means that I'm moving those triangles in my head. I'm going to try to draw you something three-dimensional here. I'm going to take that. In my head, I rotated that. It looks almost identical to what it was to begin with. But in my head, I took it and rotated it a little bit so that we can imagine a whole bunch of equilateral triangles. Oh, I feel like I'm failing a little bit in my picture drawing. Yeah, this is for your own safety. Imagine you never saw that. It's hard to do that kind of drawing. When I closed my eyes, I drew beautifully. So we're going to go from 0 to 1. We've got our formula, which is root 3 over 4. This, the base, is going to be the one function minus the other function squared. Just plug it in. Smartboards are cool, but I imagine one day I have like something that projects and I can actually show you things three-dimensionally and I can like move them in. They have that in movies, right? Should be able to do that in classrooms. Okay. How about an isosceles right triangle? What is an isosceles right triangle? Well, isosceles means two sides are the same. Right means that you've got 90 degrees. I hope you can tell which is the other side that's the same. Mathematically, only one is possible. It has to be this side. Otherwise, the hypotenuse would be the same length as one of the sides. Somewhat problematic. And this, again, base times height divided by 2. Wow, that is not a good looking 2. Here we go. Base times height divided by 2. Well, if it's isosceles, the base is the same as the height. So we get that s squared in there, right? Problem with writing the formula this way is you've got two variables. So we're always trying to write it in terms of one variable. So if our base is s, then the height is s, and you just get 1/2 s. So we could do same shape, perpendicular to the x-axis, so there it is. And now the one side is straight up and the other side is a triangle. I just had a beautiful visual in my head that I probably can't draw for you. Try to take that, rotate it in your head, and imagine one cross-section being a perfect isosceles right triangle. So again, because we're going up and down, we go from the x values. The top one is the square root of x, the bottom one is x squared. Just plug it into the formula, and you find that volume. Again, I would say cross-section areas are not too bad. You just have to know how to find the area of one of those shapes, and then you're just integrating along the way, just adds up all of those shapes as you go along. Semicircles. If you know the area of a circle, I am hopeful that you can figure the area of half of a circle. Uses some high-level mathematics, but it's too much to explain here, so you'll just have to accept the 1/2 pi r squared. Now, if you had, well, yeah, we're going to have that same shape again. I'm pretty sure my notes, I didn't get creative at all with this. This is This is me on the very last unit of making notes after I made tons of notes of like, I'm going to keep the same shape. Okay, but we have that same shape, and this is going to be the radius. Oh, look at that beautiful semicircle coming off of there. Okay, this is from here to here. That's your radius of your semicircle. So if I figure out the diameter, which is the top height minus the bottom height, does it make sense that your radius gets cut in half then? Which is going to get a little ugly looking when we plug it in, but if we have our calculator, this isn't bad. Oh, that's a creative example. Okay, let's use this one. And, perpendicular to the x-axis again, right? Not straying too far. Keeping life simple. You guys are also at the end of a very big course, so keeping things simple at the end is not a bad thing. And so our volume, with it being a semicircle, okay, 1/2 pi r squared, and the radius would be the top one minus the bottom one, cut in half, all squared. You could square it out if you wanted to, but no, I didn't actually. I'm missing a square here. Still would have a square there on the top. I just squared the bottom. And plugging that into our calculator. Get the volume. As like a drum roll, I'm adding special effects to my videos now. Last example of your notes. You ready? Good? Everybody good? Yes? Okay. A solid has a circular base of radius 4 centimeters. Find the volume of the solid if every plane cross-section that is perpendicular to a fixed diameter, this is the visualization of this one is what is going to be what is the most difficult, is an equilateral triangle. Okay? So, there's our circle, that's the base. If you fix a diameter, let's say I fix this diameter here, then each of these are going to be equilateral triangles all the way through. Can you imagine a pointy part all the way up here like this? And they start off with little equilateral triangles and get wider until we got a big point here, and then it goes back down to the beginning. Equation of a circle. If the origin is at 0, is x squared plus y squared equals the radius squared? Because it's just basically Pythagorean. If you picked any point on that circle, you can make a right angled triangle. X coordinate plus the y coordinate has to equal the radius squared. This would allow you to get the y by itself. If I get the y by itself, I'm actually wanting to do this, right? Perpendicular to the x-axis. I could get the x by itself. It's going to be exactly the same answer, because you could take whatever shape you get and rotate it. But this is technically what I'm doing by getting my y by itself. Equilateral triangle was that root 3 over 4. We're going to take our radius, our diameter actually, and square it. Okay? Now, if you got the y by itself, does it make sense that normally you have plus or minus here? Technically, the way that I've written it here, this part is only the top semicircle. The minus part would be the green part, would be this part. And so when I figure out this y value, that y value goes from here to here, because I've only done the positive part. I would need 2 of them to get my base. So I sort of got it in this picture here, showing 1 of those. I would need 2 of them, that's why there's this 2 outside in front. Okay? Again, the setup is the challenge. Once it's set up, I could simplify that. I'm going to integrate from -4 to 4. And we get an answer. I don't think they'd ever give you one this complicated on your exam.